In landscape on my phone, your chin is cut off, but if I hold it up and down, you're good proportion.
Nice.
No, man.
Keep it in the good proportion one.
We are good. Let's rock it.
Hmm?
Dude. This is sweet.
Yeah, yeah.
All right.
That's cool.
All right, cool.
How you
Ready to
figured
roll
out
then?
How to do that? Cool.
Dude, Shane
Yeah,
figured it
I'm gonna
out.
be quiet.
Nice. That's cool. You can force people to receive briefings now. Amazing. Cool.
Yeah, exactly.
Impressive.
All right, cool.
Impressive.
I'm gonna start here. So a little intro to kick us off. This is gonna be a paper by Ryuyang Wang titled "Re-examine the Principles of Special Relativity and the Sagnac Effect Using GPS Measurement Equation." So we're all told that GPS, has to account for special relativity effects such as the invariant speed of light, time dilation, shit like that, right? And without accounting for those effects, GPS would be inaccurate. It wouldn't work, blah, 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 right? Well, it's actually, not only is it the opposite, it would only work, it only works under, well, it works under different transformations, but it works under a real specific preferred one that works out really nice. So that's what Wang is going to point out here, and he's going to talk more about that. I'm just going to read from the paper, and then I'll do some summaries at the end of each section. So abstract, successful GPS operations are based on the equation of the range measurement equation. And that's the absolute value of R sub R times T sub R minus R sub S times T sub S equals C times T sub R minus T sub S. And we'll get into what all this means as we continue on. In an Earth-centered inertial system. So this is really important. We'll keep this in mind for later on what that means as we continue. The calculation is based on this equation to show the correctness. The calculations based on this equation show the correctness of the equation leads to the incorrectness of the two principles of special relativity, the principle of relativity and the principle of the constancy of the speed of light. And what he means by the first one is relativity's first postulate. That is, all inertial frames are equally valid, which will be shown to not be true with the issue with global simultaneity and relativity simultaneity, where multiple events are happening in the same frame, which GPS is entirely dependent on, which is a violation of special relativity. So like violations all around, really, if you think about it.
Wow.
Not just the speed of light. It's like it's an absolute body bag.
That's a violation squared with a subscript. Sorry, go ahead.
Yeah. So the Sagnac effect can be fully interpreted by this equation as well, and therefore the Sagnac effect is a non-relativistic effect, which we'll get into as the paper progresses. It is indicated that the relativity of simultaneity of special relativity contradicts the basic operational principles of GPS. Moreover, based on the range measurement equation, it is expected that we should take a practical and crucial experiment that does not require any clock synchronizations, and that will give contradicting results to special relativity. The crucial experiment can be further simplified by using GPS. So basically, this dude's going to turn GPS into a big giant laser interferometer and just body bag the whole network. But obviously within the globe paradigm, but we'll just go ahead and co-opt that as well while we're at it. So when we should conduct the crucial experiment, yeah. So he's pushing that we should all test for this. Now, if nobody's hasn't heard anything from this guy about winning any awards for disproving special relativity, it's probably because nobody took him up on his proposal here, because it would lead to direct definitive results that nobody could walk away from that absolutely obliterate relativity. So continuing, the GPS is a time ranging system. The operation of GPS are based on the range measurement equation in an Earth-centered inertial frame, the ECI, an idealized air-free situation. So the ECI reference frame, from their paradigm, what they're equating this to is being at the center of a ball where they're experiencing no motion and no rotation of the ball, the center of the Earth. And but what they do say, how they do equate motion, right, of a stationary object on the surface of the Earth. If you're at the center, the surface of the Earth is obviously rotating around you at 15 degrees an hour, right? So they do equate motion in that regard, but that's one transformation equation away from just being an ether wind in terms of rotation, right? So not a big deal for us. We're still super solid. And then we'll continue on here. So he reiterates the range equation again, the absolute value of all this. And then here, T sub S is the instant of transmission from the signal from the source. T sub R is the instant of reception of the receiver. R sub S times T sub S is the position of the source at transmission time. And R sub R times T sub R is the position of the receiver at reception time. Highly successful practices of GPS, especially its unprecedented precision in measuring distances up to the order of millimeters, equivalent to measuring time to the order of 0.01 nanoseconds, have proved the correctness of GPS's range measurement equation with high accuracy. Based on that, we re-examined a fundamental problem in physics. The two principles of special relativity, which is the all inertial frames are equally valid, and the principle of the constancy of the speed of light, and the unsolved fundamental problem in physics, the Sagnac effect. Oh, what a weird thing to say. Isn't the Sagnac effect a relativistic effect predicted by relativity and all these things? That's a weird thing to say. I wonder why you'd say that. So anyway, the Sagnac effect, which is extensively used in GPS. Oh, that's weird. Why are they calculating for preferred direction in the propagation of the speed of light in GPS? That doesn't seem like they should be doing that. Anyway, here we emphasize the important parts first of the three most important parts of this, or points that this guy wants to make moving forward. Here we should emphasize the three important parts first. The correct coordinate frame for the range measurement equation is the Earth-centered inertial frame. So this is going to be really important as we move forward. Most GPS receivers are moving relative to the ECI, e.g. receivers on the ground station, airplanes, cars. So remember when I was talking about earlier, they're equating a ground station being in motion, but it's actually just stationary, and it's an ether wind because it's all about the direction of the propagation, right? That's giving the preferred speed, which is causing the, what would it be, like the inaccuracies, I guess, so to speak, if you don't account for it. So obviously the definition of the position of the receivers at the reception time is more important for a moving receiver, not more important, is important for a moving receiver, since at the reception time, the position of the moving receiver is different from the stationary receiver. 3, the range, P, is the absolute value of R sub R times T sub R minus R sub S times T sub S, is not the distance between 2 points in its traditional meaning. Traditionally, the distance between 2 points is the distance between 2 points at a given time, e.g. D sub 1 equals the absolute value of R sub A times T sub 1 minus R sub B times T sub 1. The range P corresponds to the distance between the position of the satellite at transmission time, T sub S, and the position of the receiver's antenna at reception time, T sub R. This is the range P, or that is, the range P is the distance between 2 points at different times of reception, of transmission, and times of reception. The additional distance is invariant for the coordinate transformation between two moving systems relative to each other. but the range P is not invariant even under the simplest transformations. So what they're saying here is that under or using this equation and assuming a stationary non-rotating Earth, you can derive the distance between the GPS and the person, right, by the time it take. They basically just do timestamps, so it just takes a snapshot of when it sent the signal and then when GPS gets when the signal is received, right? And that's how they derive the actual true distance, accurate up to the millimeter effect, right? Now when they transfer it to another coordinate system, that distance changes, which isn't supposed to happen if you're using the right shit, right? Otherwise, you're going to have to apply corrections after the transformation. So what he means by a simple Galilean transformation is he's just going to change one axis on the coordinate system. So I'll read you through what he's doing here, and it'll kind of make sense what he's talking about. So suppose we have two coordinate systems, S and S prime, and the transformation between S and S prime is X prime equals X minus VT, V times T, and then Y equals Y prime, and Z equals Z prime, and T equals T prime. So what he's doing here is he's defining the XYZ axis, and then for the new coordinate system, it's derived from the old coordinate system. So the only axis that's being changed here, the only coordinates. Yeah, 1 second, dog. Yeah. Yep. Thank you, Shane. So the only coordinate system here that's being changed is the x-axis. So basically, he's just adding motion. So just one axis is changed, and in doing so, it changes the way that distance is calculated. So that's no good for a transformation unless you're going to have to apply extra shit. So when they say like, oh, we have to apply time dilation on all these extra corrections, well, they only have to do that if they transfer it out of the initial thing that they already measured it in the first place that works perfectly accurate on the stationary non-rotating Earth with the preferred direction of propagation. Like everything is already accounted for in this equation. So when they transfer from the ECI to the ECEF, right? So that Earth-centered, Earth-fixed, so basically the same as this, but the way that they imply rotation is different. It would be like your perspective is on the surface of it rather than at the center of it experiencing no motion. So anyway, just by adding motion to the receiver, they mess up their distance, and it requires additional calculations. And this dude's like basically saying, why are we doing this? It already works fine. And then on top of that, there's some other stuff that we'll get to. So we'll just keep reading here. Here we will discuss the implications of GPS to one of its foundations, or to one of the foundations of modern physics, special relativity. GPS has in fact provided a big laboratory and instruments for the test of special relativity, moving sources and moving receivers, accurate atomic clocks in both sources and some receivers, precise knowledge of positions and sources and receivers and long distances between sources and receivers, signals carrying the information of positions and times, etc. Almost all of the needs for the test of special relativity, although one would think that based on the successful practices of the unprecedented precision of GPS, a conclusion about special relativity could have been made. So far, a common opinion has not been reached, and sometimes completely opposite opinions are held by different people. Oh, no way, but doesn't GPS prove fucking, the Earth's a globe and all this shit? Which, obviously from their paradigm, it's a solid globe, but doesn't it prove relativistic effects and all these things? Like, not according to the guy who understands the math extremely well. So let's listen to his analysis of the situation. Some people think that the range measurement equation is based on the constancy of the speed of light. On the surface, this may appear to be true. C, the speed of light is the only velocity term that appears within the equation. Expressions such as C minus V and C plus V, which are often seen in discussions of special relativity in classical physics, do not exist in this equation. Therefore, some people would conclude that if this equation is correct, special relativity is correct. If this equation has been proved to a high degree of accuracy, then special relativity has been proved to a high degree of accuracy. For example, it has been concluded that special relativity has been confirmed to delta C over C less than 5 times 10 to the minus 9. So, really small, precise measurement or whatever they want to call or pretend. Oh, thank you, Shane, for the graphic. Feels like Nazi Germany. Things by their appearance, we should try to grasp their essence. If we analyze the implication of the range measurement equation carefully, we will find that contrary to what appearances tells us, What some people think the correctness of GPS's range measurement equation actually leads to the incorrectness of special relativity, or the principle of the constancy of the speed of light, and furthermore the principle of relativity, which is the all frame situation. So this may seem unexpected, but it is quite understandable if we compare it with sonar systems. Recall that in underwater navigation, sonar uses the same range measurement equation as a reference frame based on water to calculate the distance traveled by sound, even though the sound receiver is moving relative to the water. The difference there is that the speed of sound in water is used instead of the speed of light in a vacuum, C. However, no one would emphasize the constancy of the speed of sound, and contrarily, everyone thinks that the speed of sound is dependent on the motion of the sound receiver. So really, really good analogy there. Like just a simple changing of the medium and the type of wave, and suddenly this equation has wildly different interpretations, you know? So, so to continue on, the range measurement equation, a moving source and the speed of light is independent of the translational motion of the source. So here he's talking about, second. Okay. Most GPSs move in circular motion. GPS satellites and DGPS sources moving with the rotation of the Earth, or ether wind. But from a theoretical viewpoint, we will only investigate sources that are moving translationally and uniformly. So what he's saying here is special relativity predicts that if S1 is a stationary source emitting a signal, and S2 is a moving source emitting a signal, if S2 is moving along this line right here, right? If it's moving along this y-axis, and right as these 2 points, you know, are at the same level and they intersect or whatever, and they both emit a signal at the same time, the stationary recipient receives them both at the same time. So that's in alignment with the you know, speed of light or whatever the propagation is irrespective of the motion of the thing emitting it, right? So it doesn't cause any hiccups there. Everything seems on the up and up so far. So I'll just read his conclusion real quick. Therefore, we can conclude that the speed of light is independent of the translational motion of the source. Cool story. Now we get to an issue. The range measurement equation and moving receiver and the speed of light is dependent on the translational motion of the deceiver. Most GPS receivers are moving too. Some of them are in circular motion, e.g. the receivers are on ground stations and are fixed to the Earth, so the Earth rotation fixed, ether wind, same thing. Some of them are in a translational motion. They're on missiles, airplanes, cars, etc., trains, all that. So let us suppose that we have a stationary source and 2 receivers, one stationary and one moving translationally, the distance between the source. So basically just an invert of what we just witnessed, right? And what he finds is that now these guys should both receive the signal at the same time, a stationary source emission and a moving receiver. So the moving receiver is moving up here, and as soon as he gets, you know, directly in the same position as this guy, the GPS signal is sent. They should both receive the signal at the same time, but the stationary guy receives the signal first, according to the math, and that's a huge problem for special relativity because they should both receive it at the same time, as special relativity is all about velocity and all that, and how that affects light. And so that's a real big problem for them. Continue on. So for a signal transmitted to the source at T0, the 2 receivers, one stationary and one moving, will receive it at different instances, although the distance between them at the source is the same. Therefore, we can conclude that the measurement of this, or conclude that the speed of light is dependent on the translational motion of the receiver, not in alignment with special relativity. Contrary to the appearance of the range measurement equation of the receiver, V does not appear explicitly in the receiver. The speed of the receiver is implied in the definition of the position of the receiver, i.e. the position of the receiver when at the time of reception, right? So remember how this is a timing-based system. It's not measuring distance. It's seeing how long it takes for two signals to be, you know, sent and received, and then it subtracts, what was it? The reception time and the transmission time from the speed of light. So compared with the position of the stationary receiver at reception time, the position of the moving receiver is different from the The reception time is different, and the difference is proportional to the speed of the moving receiver. So for some reason, a moving receiver affects this, right? So not clear on why that is. It's a mystery to me, honestly. So we'll get into the simultaneity problem. So this is more along the lines of the first postulate, where two events can't happen in the same reference frame relative to other observers. So because then everything, because it becomes a whole problem for them, a whole paradox. So the global simultaneity and versus relative simultaneity. In any debate about the speed of light, the problem of simultaneity is always the focus. Special relativity claims that the relativity of simultaneity, which states that two events occurring at two different places, which are viewed simultaneous from an observer, usually will not be simultaneously if viewed from another or from an observer from another system. Now he says usually very generously here. There's no room for usually. It's never, ever. But contrary to this, simultaneity is key to the GPS operation. GPS is a timing ranging system. It does not directly measure the distance between two places where two events, i.e. signals transmitting and receiving, occur. It measures the difference in the instance between when these two events happen, and the distance is calculated using the range measurement equation. GPS, especially its space segment and control segment, make huge efforts to establish and maintain a GPS system time. So basically, this is just like a universal timestamp for GPSs to follow when it's sending out signals and receiving it. These are multiple events happening in the same instance, and they're being received and sent back and stuff, within the same instances as well. So it's all like that doesn't happen in relativity, in special relativity. And the GPS system and being how it maintains being in sync with everything is literally entirely dependent on multiple events happening in the same frame, and also for all of the other observers, like while still being in sync, right? And this is all accounted for in the equation that specifically doesn't account for any relativistic effects and doesn't require any corrections if you use it in its proper coordinate system, which is a stationary, non-rotating Earth.
Yeah, Earth-centered Earth.
Just making sure we're all on the same page. So GPS, especially the space segments in the scope of blah, in the scope where GPS is applied roughly with a diameter of 50,000 kilometers or one bigger. If using GPS, one is using GPS time. Therefore, the concept of simultaneity of GPS, two events happen at two different places. Here's your coordinate system for event one, the coordinate system for event two. Excuse me. Are simultaneous if T sub 1 equals T sub 2. This is true no matter who the observer or receiver is, where the receiver is, what the status is, or what the speed is. This is the basic operational principle of GPS. We call it global simultaneity. So, like, I don't believe in relative simultaneity, but like, tell me more about this global simultaneity, or maybe, obviously we're going to rename it planar simultaneity, but, for now they can keep the globe branding for now. So in the books about what's up,
real quick. So the GPS doesn't actually measure distances. So it takes the coordinate system from 2 points. So X, Y, Z, Z, right? So like Cartesian coordinate, and then it compares it and puts those variables into another equation, which takes those two equations, those two sets of coordinates, and then outputs the exact distance based on that geodal distance. Dude, isn't that how, like, so that would be how Google Earth works? That's how they hide spherical excess in large cities and use Google Earth to make those triangles and lay it over the map and go, haha. But really, it's this translation formula, which isn't doing the distance in real time. It's just giving you the computed distance based on this geodal long lat system. Holy cow, man.
Indubitably, my good sir. So we'll continue on. In the books about special relativity, the commonly cited example about the simultaneity of relativity example is the railway platform in a moving train. It says that two events, i.e. or e.g. the two strokes of lightning A and B, which are simultaneous with the reference to a platform, are not simultaneous with respect to the moving train and vice versa. So if you've ever seen that thing where they got the train car and there's a guy halfway, in the middle of the train, and the lightning strikes both ends, and it's like, which one will they see first? And the platform observer sees them both happening at the same time, but Einstein says the guy on the train will see the first one happening, the one that's, in front of him first, or some shit. And basically, so what he goes on to say is that but GPS receivers have have been utilized extensively on railway platforms and moving trains, and lightning at two different places, A and B, conceptually at the same time, as the emissions of GPS signals from two satellites or two DGPS stations. So basically, the thought experiment analogy, come up with that they used to teach relativistic effects is entirely contradicted by the practical use of GPS. In fact, two signals are emitted from two satellites or two DGPS systems at the same GPS time. Both GPS receivers on the railway platform and the GPS receiver on the moving train would acknowledge the two events, and the emission signals would be simultaneous without this basic acknowledgement. The GPS receivers cannot function at all. Oh, no way. So it's actually a direct refutation if you try to invoke the way that they say that light works and stuff for special relativity. The range measurement equation in the crucial experiment for relativity. So this is where he's going to propose a test that can be done, and basically what the test is, it's kind of what we already read here. It's what was it? Two observers moving in different directions. I'll just read it out. Fuck it. All right. We have shown that the correctness of the range measurement equation contradicts the principle of the constancy of the speed of light, which asserts that light in a vacuum has a definite speed of propagation that is dependent of its state of motion of the observer. We also indicate that the relativity of simultaneity contradicts the purpose of a GPS system time, which is the basic operational principle of GPS. Due to the popularity of special relativity, a lot of people will not accept these. Therefore, we will examine a crucial experiment in which the results can be used to refute or verify special relativity from everyone's point of view. More importantly, in this experiment, simultaneity or the use of synchronized clocks is not a concern, because they'll always try and wiggle out of a simultaneity violation or a clock synchronization. They'll just chalk it up to time dilation and just whatever they can to get out of this whenever it contradicts it. So this dude's saying, I got a pretty solid one we can do to bang this out real quick. So we mount two atomic clocks with the same construction, signal emitters, reflectors, receivers at two ends at points A and B of a vehicle with a distance of L between A and B. The vehicle is stationary relative to an Earth facing north-south, or facing south or north, doesn't matter. So that when the vehicle moves in the direction, its velocity is north or south, eliminating the effect of Earth rotation or the preferred direction of the ether wind. This is just to try and get a baseline without sending a signal, into that propagation or against it, right? That's what they're trying to do, or what he's trying to say by that. Even though they equate the same thing to Earth rotation, that's what he's saying. So the two clocks are not synchronized with each other. The signal transmitted from A at T sub 1 times A according to clock A to B arriving at T sub 1 times B according to clock B, and reflected back at A arriving at T sub 1 times A according to clock A. By the readings of the clocks, we can calculate the difference in the nominal traveling times for the two directions. And let me see here. I got notes on this real quick. Let me just sum this up. Four. So comparing the stationary recipient A and the moving receiver B, the signal reflection times on the north-south axis are used to deduce whether or not C is truly invariant. So basically, what already works, he's just proposing a more extreme example of it, with particulars where they're going north-south specific, like in a specific alignment, just to be double extra accurate or whatever. And what he's already put forward shows what the results is going to be. It's not going to go well for relativity, but this is an experiment that was put forward that nobody on their side will do. So we'll just continue on with that. So hence, according to the range measure, this is where he's talking about if they were to try and say that there was a length contraction or time dilation effects, the length contraction would be a second order effect in this case here, so it wouldn't apply to changing the speed of light or anything like that. And the time dilation effect of moving clocks is irrelevant because they don't have to be in sync, right? It's just recording the time of the transmission. So also the effects of the moving clock time, constancy, the Sagnac effect. Okay, so we'll move into the Sagnac effect and how this all plays into it. So remember how earlier I was talking about there's this preferred direction of propagation and all these things that they have to account for. Well, it turns out that the range measurement equation that they use already accounts for everything, already accounts for the Sagnac effect, already accounts for this preferred direction of rotation. And this is just kind of what he's going at in this part. I'll just read a little bit of it, a little bit of the summary. So the Sagnac effect and the Sagnac correction. Then a reasonable correction is, when do we add the Sagnac effect to the calculation of the traveling time of the signal? Here it is useful to identify the difference between the two terms, the Sagnac effect and the Sagnac correction. The Sagnac effect is an effect or phenomenon compared with a stationary receiver in an Earth-centered inertial frame or stationary non-rotating Earth. A moving receiver relative to the ECI will receive the signal from the source at a different time. The time difference depends on the distance between the source and the receiver and the relationship between the directions of the direction of propagation and the direction of the moving receiver. So again, more the way that they're trying to equate it obviously is like, are you rotating with the Earth? Are you rotating against it? Like, you know, what do you do? Who's your favorite rotation? That's just, you can easily just equate it to, you know, east-west propagation in the direction of the ether wind, right? So the Sagnac correction is the correction added in the calculation when we use the range measurement equation. I'm sorry, the Sagnac correction is a correction added in the calculation when we use the range measurement equation. In fact, if we use the range measurement equation in its original meaning, i.e. range being the distance between the ECI, between the source of transmission time, being the distance in the Earth-centered inertial frame between the source of transmission time and the receiver at reception time, no correction is needed. The Sagnac effect is included automatically. That is, although there is a Sagnac effect, there is no need for the correction. However, if we utilize the range measurement equation differently from its original meaning, we need to add a correction. Usually there are two cases. One, the range is not in the ECI, but rather a different coordinate system, because the range is not invariant from the coordinate transformation, as we mentioned before. So again, when you transform the distances to a different coordinate system from the ECI, it's going to give you an inaccurate result if you don't account for the Sagnac effect in the new system, because it's already built into the first one. And two, the range is not the distance between the source, but at the transmission time and the receiver at the reception time, but the distance between the source and the receiver time, but the distance between the source and the receiver at the same time, the transmission time. Therefore, the Sagnac correction must be added to compensate for the difference caused by the incorrection of the definition of range. So again, when they're changing coordinate systems, they're changing how they're trying to define how they're using GPS. I'm guessing like that's how you could look at it. And to correct for that, they have to make the necessary corrections, or they're going to be inaccurate. And then I guess that's probably where they get into saying things like, this is how we account for time dilation and all this shit, but it's really just them trying to apply it to the, what did you say earlier, Shane? The globular lat long coordinate system?
Yeah, so when you went over how that actually computes distance, dude, like the whole thing clicked for me. It's like simultaneously I understood how they hide distances in Google Earth, how they claim spherical excess between 4 long cities on a giant thing. I'm like, well, they're not even writing distances. They're just imputing it into this formula, which will spit back out the correct adjusted spherical excess pre-included geoidal measurement from those two distances if it were a sphere. That's exactly how it's done. And I hadn't quite understood that. So that's why I hopped in. Was like, oh my God, I think I get it.
Yeah. Yeah, dude. I mean, thanks Wang, right? Make sure you thank him.
Dude, I gotta figure out who Wang is, and then I'm gonna thank him. And then we gotta make a meme that thanks Wang, so we can get others to thank him.
Absolutely. Okay, so let's see here. I think here he was just talking about the same situation with the Sagnac device. So when you apply the corrections to the Sagnac device to derive, you know, the friendship pattern and all that and how it should work, you do the same thing for GPS basically, and that's what he's saying here. So we're almost wrapped up here. The Sagnac effect and the Sagnac correction and the translational motion, including uniform motion. There is a misconception that the Sagnac effect, a first-order effect, uniquely belongs to the rotational motion, although it is true that for the interference experiment, the necessary condition for the Sagnac effect is rotation. Now, keep in mind, this is a guy that thinks that the Michelson-Morley is a null result kind of thing. So, like, this is why all these people talk like this, and they think that the Sagnac is the only viable interferometer for that. It is because for an interference experiment, the light path is a enclosed one, and for this closed light path, the possible Sagnac effect caused by the translation of motion are canceled with each other, like the effects in the Michelson-Morley experiment, which only detected a second-order effect. Now, the signal propagation in the GPS is a one-way propagation. There will not be a cancellation. Therefore, the rotation is an unnecessary condition for the first order Sagnac effect anymore. So that's pretty devastating right there. So this is all based on a one-way, like the one-way speed. So like from the source to the receiver is how this is all calculated, and it's showing that there's a need to account for a fringe shift pattern, or I mean, for the same thing that they attribute to causing the fringe shift pattern in the Sagnac device, which would they attribute that to rotation, but they say in instances where there's no rotation, it still does it. So that's pretty puzzling for them. Here we will show that for purely translational motions, including uniform motions, the discussions about the Sagnac effect and the Sagnac correction are suitable too. There is a Sagnac effect when the receiver is in uniform motion, and that we need to add a Sagnac correction if we use the range measurement equation not in its original meaning. And again, not in its original meaning would be the Google Earth coordinate system. So let's see the Sagnac correction. Define you. Okay, so it just goes on about that. Same propagation. So I'll go ahead and read this out. We're almost done here, boys. This result is the same. This result is the same as the result of the Sagnac correction for the signal propagating from a satellite to another satellite, as mentioned before. In fact, when delta t equals tr times minus ts is short, there is no difference between the motion of the satellite, which is the circular motion, to the receiver, which is the translational motion. So no correction. Does that this result the same from another satellite? So no correction needed. Finally, we would summarize the following for the Sagnac effect for the correction one, or for corrections. One, the Sagnac effect is caused by the motion of the receiver in an Earth-centered inertial frame. So remember, if you're stationary on the Earth and the Earth's not moving, and you're still needing to account for the directional propagation, it's the ether wind, right? So there's that. We should add the Sagnac correction if we use a range measurement equation in the coordinate system from a frame that is moving relative to the ECI, or if the position of the receiver is not at the position, not at the instance of the reception, but at the instance of transmission, whether the motion of the receiver is circular or purely translational. Therefore, the Sagnac effect is not a relativistic effect, and contrarily, it is a non-relativistic effect. So specifically, not only is he's saying, like, not only is it not a relativistic effect, like it's an effect and it has nothing to do with relativity. He's very clear about that. And another thing that I forgot to talk about was the corrections that they do. So for the simultaneity things, what they can do is after it's been calculated, or after it's been set and all that, they can do a post calculation using the range measurement equation with the ECI and like reverse engineer the distance, even if they don't have it properly recorded or something like that. It was back here. I missed it, but basically that was what he was talking about when he was talking about the reasons for applying the correction might be different, but the result ends up being the same. So it's like a backwards compatibility kind of thing that just kind of further shows how awesome the intended coordinate system is when you're using it to actually do what it's intended for. And this is back to wrapping up the experiment. We'll just read the conclusion here. Up until now, all experiments used to verify special relativity have been done with an Earth as the reference as the task. Up until now, all All experiments used to verify special relativity have been done with the Earth as the reference frame. And for the speed of light, there has never been an experiment in which the receiver is linearly moving relative to the Earth. Therefore, the two principles of special relativity, the principle of relativity and the principle of the constancy of the speed of light, have never been fully verified by experiment. What? This was written in 2002. I thought relativity was proven. Citation, reference 13, which we'll look at here in a second. The calculations based on GPS's basic equation and the range measurement equation show the correctness of the equation leads to the incorrectness of the two principles of special relativity. The Sagnac effect can be fully interpreted by this equation, and therefore the Sagnac effect is a non-relativistic effect. It is indicated that the relativity of simultaneity in the of special relativity contradicts the basic operational principles of GPS. Moreover, based on the range measurement equation, it is expected that a practical and crucial experiment that does not require any clock synchronization will give a result contradicting the two principles of special relativity. The crucial experiment can be further simplified by using GPS. Therefore, if the scientific contention cannot settle this dispute, this crucial experiment will. We should conduct the crucial experiment and re-examine and reconstruct special relativity starting from the grounds up, or starting from its foundations up. So the last two references here. So these two papers are really cool. Reference number 12 was the different ways that the Sagnac effect has been, derived and interpreted and predicted by relativistic effects. It hasn't really, like, spoiler alert, but this is just different iterations of how they try and explain it and co-opt it. And 13 is the linear Sagnac effect, an experiment done by the same guy who basically does a linear Sagnac motion. So remember how they were talking about the Michelson-Morley was a null result? Well, this dude basically did a linear Sagnac, which would be equivalent to doing a Michelson-Morley. And he found that there's a preferred direction in the speed of light. Like, what a surprise, right? So he double extra banged it out. This dude has an extensive body of work available on my Telegram and on the ADL Telegram if you guys want to download that and dive in. All of his work, like with interferometry, just absolutely body bags the idea of the constancy of the speed of light and anything put forward to make the effect conform to relativistic to the relativistic framework. Any thoughts, questions, or concerns, boys?
Yeah, that was awesome. I'm sure we could open it up to the general thing. We have a good recording going. Plus, good 20 people on Rumble hopping on nice and late and early. That's cool. Thanks, guys.
Awesome.
Dude, that was epic, Alan. Again, awesome, dude.
Thank you, brother. Thank you. All right. Well, that's all I got for this. So I'm gonna go. Oh, sorry. Go ahead, Crypto. You're good.
I was just saying, really enjoyed it. Thank you.
Cool, man. Thanks. All right. Well, that's all.
It's sold GPS, dude. That's awesome. So again, not only is it not proof of the globe, but so the takeaway, right? Main focus is it uses an Earth-centered framework for every translation as its origin, no matter what, all day long, every day. So that's the end of that. And then they translate it back to this geodesic Cartesian coordinate system, where they then compute distances and coordinates completely accuracy to the sphericity of the model, not to the actual plane, dude. That's how they do it. That's how they hide long distances. That's how spherical X-sets gets crammed into Google distances. That's how Google Earth distances are wrong, etc., etc. Well done.
Yeah, thanks, man. I mean, thanks, Wang. I'm just a guy that read the PDF, All right, I'm gonna end my thing. So you're good to close out whenever you're good. I forgot to record that, so I'm gonna go ahead and.
Nice. So thanks everyone for stopping by.
Welcome to the show where you don't know if it's part of the show. Welcome to the show if you don't know it's part of the show. Didn't may teach you to reach for the stars while opening up the bars and keeping you chained down with mortgage bills and cars. Vaccines for your arms, kids sounding like supercharged, caffeinated hate-filled scars and rage-quit repertoires. No answers for yards, caught up in emotion that's not even yours. Imposter truths like impeccable retards, lined up for your serving of gish galloping wars. No remedy can save the lost, in love with the yarn. I'm tired of walking into refracted shards, poor science displayed by disgusting bards. Soaked in sin with your dupe is delight in a new hand of cards. Been so long, seems like for love I'm just too hard, I'm just too hard, I said. Welcome to the show, where you don't know if it's part of the show. Welcome to the show. If you don't know, you don't know. Intoxicated 8 makes you believe you're spinning in space while you have no shame or grace. It's a disdainful state I used to contemplate, how to save myself from my own self-hate. Wonder why I was even made with a dreadful fate, forced to try and awake with a full plate, no one to help me stay awake or educate. I've had to liberate and fight through hidden gates, but my brother, heaven could never be late, and rockets don't work in space. It's all fake, the show is on Mars, it's a joke, but you're too far gone, it won't be long. Fepe's beak is strong. We have our song and we march along like streams of knowledge leading to God's holy pond, and lives of truth that hits the bong and sings the song, turns mankind from the wrong. We come in peace with a holy gown and all of us wearing our holy crowns. So the earth is flat and we probably just won't get along, just to go along, I said. Welcome to the show, where you don't know if it's part of the show.